Oh, quarters. This is I think mine was valid. That's my favorite injury.
This is a lot to ask of you in day one, but at the same time, I don't want to insult you by insinuating that you can't handle this. So we're going to just cover a lot of ground. The good news for you guys is that almost none of it is very difficult at all. So the goal before you leave here today is that you'll understand the answer to this question: what is a complex number? The second question: how do I graph a complex number? The third question: what is the modulus of a complex number? The fourth question is, how do I add and subtract these things together? And then the last question is, how do I multiply them? There's more to it than that, but I thought that this would be a reasonable amount for us to knock out in day one. So, yeah, let's get to it. So first off, a complex number is something that looks in this format: a plus bi. And I'm going to write some examples of complex numbers up here on the board. By the way, I should say this out loud, that literally every number you've ever seen, ever in your life, has been a complex number. So the complex number is a very overarching term, and it applies to real numbers and imaginary numbers alike. So even if you were to say, nah, what about like the square root of -3? It's a complex number. So the complex number is the granddaddy set of all numbers, and it has subsets of numbers, namely, again, the real number set and the imaginary number set, but they all fall under this roof of being complex numbers. So here are some examples of complex numbers, like 5 plus 6i, 3 minus 2i, -11, 4i. Those are all examples of complex numbers. The third one is the one that usually catches people's attention the most. Why? What's interesting about the third one?
It's a number.
It's just a regular number. It's like what you're used to seeing, right? It's what we call a real number. The other ones happen to be forms of imaginary numbers, but -11 is still, again, he still falls under the roof of being a complex number. He's just missing part of himself, but that doesn't change the fact that, if someone put a gun to my head and said, I require a demand of you that you write the third one as a standard form complex number, what could I do? Could I make it look like this?
Yeah.
What? How? Nope. Yeah, just make your B 0 and just add on a plus 0i. Not that I would want to do that. I'm just saying I can prove the point that it's a complex number just like anything else. So let's run through some basic vocab. This, vocab's always annoying, but the reason we do it is because it just keeps us from sounding dumb when we talk to each other. So we're going to run through just some kind of fundamental words here. So first off, let's talk about a. In any complex number, a is what we call the real part. Switch it up and use some different colors here for you. This BI, I'm going to circle this one. Okay. Do you want to guess what it's called? I I did. I used the word earlier. It's called the imaginary part. So a complex number consists of two things. It consists of a real part and an imaginary part. Now, if you have a complex number like the third one, I keep picking on the third one here, he has a name. And when it looks like this, when it has no imaginary part, and again, I did say this earlier, you will recall what I said this is. It's a real number. It is still a complex number, just to kind of beat that horse to death. All numbers are real or complex numbers, but it might fall more specifically into one of the subsets, and one of the subsets is reals. And so this is what we call a real number. If you have no imaginary part, you are still complex, but more specifically, you are a real number. And then the last thing I think that's worthy of note here is this last one for and what's unique or significant about him? Yeah, it has no real part, right? Has a name, and it is called a pure imaginary. So real quick, before we get to the mathy part of this, one of the things I need you to be able to do is just graph a complex number, and it's really super simple. It's really something that but I don't know when was the first time you ever like graphed a point when your teacher gave you a point like this and you had to graph it? Do you remember that?
Eighth grade.
Seventh, maybe?
Eighth grade.
Yeah. And so in the same way that you know how to go right 5 and up 6, graphing a complex number is exactly as simple as that. So like, for example, this complex number right here of 5 plus 6i, we don't graph in the Cartesian plane like you're used to. What you're used to is graphing in the XY standard coordinate plane. We're going to change our axes, and no longer are they the x-axis and the y-axis. And so when we graph a complex number, we're graphing in something called the complex plane. And the artist formerly known as the x-axis is the real axis. And the artist formerly known as the y-axis is the imaginary axis. And so if I said to you, I want you to graph the complex number, I'll use some colors here. If I said graph 5 plus 6i, it's insultingly simple. I already heard someone kind of whisper it. You quite literally go 5 units to the right on the real axis and then 6 units to the north on the imaginary axis. It feels exactly the same as just plotting a point like you've been doing for years. So the complex number 5 plus 6i can be graphed in the complex plane by going to the right 5 and up 6, just like that. It's important that you're very quick and good with that, because when we find the modulus here in just a second, that's obviously going to be the first step, is you understanding just how do I get there, first of all, and then finding the modulus is on the tail end of that. You can see that there would be a little bit of uniqueness if I had you graph say a pure imaginary. So if I gave you a pure imaginary number like -3i, how do you suppose you'd graph that? Just go down 3, right? If he has no real part, I mean, it's technically a 0. So like -3i, I would just go down 3 and graph it on the real, or excuse me, on the imaginary axis. And then the same could be said, of course, for a real number. So if I gave you 4, is 4 a complex number? Yeah, it just happens to be a real number. How would I graph it?
Right.
Just go to the right 4. Okay. So that's the basics of just graphing a complex number. I can't think of any reason why anyone would ever miss that under any circumstances. Yeah, man.
What about,
What do you mean?
so like the one eye is that like that's enough for the eight, right?
One eye?
Um, I think that,
You mean like that?
You just
It's just a complex number, so you would just go up 1 to graph it.
so what it, okay, yeah, thank you.
You're welcome. You won't be able to find any instances in which this is not simple. I mean, you might be able to try to dress it up, but at the end of the day, it really just boils down to how much real do I have? Go right, left. How much imaginary do I have? Go up, down. Very basic concept. So the next part of this, the next follow-up in this lesson, is to find something that we call the modulus. And the modulus is going to look to you like something that you've seen before. If I took this purple one and I put it in these vertical bars, what do you know those bars as? That is correct. And this is not the absolute value. We do not find the absolute value of a complex number. The terminology changes. It's called the modulus. And it feels the same. It has a lot of similarities, by the way. You remember from the olden days that the absolute value of a number is how far away it is from 0, right? So like if this were like a 6th grade class and I said, okay, class, today we're going to learn the absolute value of -3. I would draw a number line on the board and then I would graph -3 and put a dot there, and we would count together that it's physically 1, 2, 3 steps to get there, right? So the absolute value would be 3. This is the same idea, all right? So it's going to feel like we want to say absolute value. In the context of complex numbers, we call it the modulus. And so if I said to you, what's the modulus of 5 plus 6i? What I'm actually asking you to do is find the distance from here to here. And why is that going to pose a problem for us? For any mathematician, Cody? Let me go back. Let me backtrack. Here, let me ask you the question from this perspective, and then maybe because I think I just asked you a bad question. If I asked you to find the modulus of -3i, I am asking you to find the length of that yellow line segment. Would you have any issues with that?
You don't have a unit.
Why not? What is it? What's the modulus of -3? It's quite literally 3. And why was that so easy for us? Because it's a vertical shot and you can count horizontals and verticals. You don't need a math degree for that, right? So if I'm going straight up or down, if it's a pure imaginary, that's easy. The modulus of -3i is 3. What's the modulus of 4? It's 4 because it's a horizontal shot. So let me now return to my question about the purple one and see if it wasn't your fault. You didn't understand my question. What's the rub, the problem with that one? Huh?
Finding,
Right. It's a crooked line, right? It's what we call an oblique line. And when you're dealing with obliques, it's a problem, right? It's going to be an issue for us. And so we have to know this little thing called the Pythagorean theorem, right? And it's one of the most useful things you'll learn in all of your years in math classes. So what we're going to do is we're going to focus our attention on this distance here and this distance here. Correct? Now, are we going to do this every time? No. We're going to shortcut the dickens out of this. But for the first one, let's just take a look at what we're actually up against. So if I say, hey, everybody, let's find the modulus of the complex number 5 plus 6i. What I'm really asking you to do is just use the Pythagorean theorem. How long is the bottom side of this triangle? 5. It's 5. How long is the other leg, the vertical?
6.
And then, of course, if you know your Pythagorean theorem, you know what this means. It means that we need to take 5 squared plus 6 squared equals, call it whatever you like, c squared. Don't care. What's 5 squared? 6 squared?
36.
25 plus 36? 61. And if 61 is equal to c squared, what is c equal to? The square root of 61. So we would say in this case that the modulus of the complex number 5 plus 6i is equivalent to root 61. Now, if you were taking like an ACT and someone said round it to the nearest hundredth or whatever, then you would, of course, put that in a calculator and get your 7 point, whatever it might be. Good. Clearly, you can see that we can bypass a lot of that stuff, right? Like, why would I want to draw a triangle every single goddamn time when I can see the writing on the wall? So let's practice this without necessarily drawing the triangle. Let's practice finding the modulus of another complex number, like, how about the modulus of -2 minus 4i? You could see it and you graph them until you're done. I don't care. Graph them forever if you want to, but it would be like right about here, right? That red dot down in quadrant 3. What's the math going to look like? I see some of you already churning it out in your head, but what is the math going to look like?
2 squared plus 4 squared equals 6.
Yes. So if you want to make modulus really slick and quick, you basically just ignore all the negatives. I'm going to circle something in yellow. What is that number squared? Just 4, right? -2 squared is just a 4. And then let's do it again. What's the green number squared? 16. All you got to do, my dudes, is just add them and root it. What's 4 plus 16? So we're going to take the square root of 20. And since, you're in an advanced class, you should know this. What is the square root of 20 equal to? It is 2 root 5. Remember that, how we take the square root and we break it down into root 4, root 5. So we would say that the modulus of -2 minus 4i is 2 root 5. It's really not a very difficult thing, is it? Kevin?
Okay, so with the terminology of a modulus, could you also just call what's the word now? The
While Oliver's looking for words, yeah, I'd rather you please do not call it the absolute value.
no. So since every number is a complex,
Yes.
is every absolute value also a modulus? Or
It's an interesting question. You have to bear in mind that sometimes we're talking in terms of a complex plane and sometimes we're not. And so, like, generally all the math you've done up to this point, if I said, what is the answer to this? Generally speaking, in a normal setting, we would just say, what's the absolute value of 4? But if you knew you were working in the context of specifically talking about complex numbers, then you'd switch your verbiage. It's not a great answer, I know. Context.
So absolute values is the modulus, like what would you label as?
What is the, let's practice some moduli, by the way. The plural of modulus is moduli. Let's practice some moduli here, okay? Ready, go. What is the first modulus? Modulus of 1 plus I. Try again. Root 2 for the win. What number do you see right there? What is 1 squared? 1. What number do you see right there? 1. What's 1 squared? What's 1 plus 1? Slap it in a root. Root 2 is your modulus, right? Remember, there's ones all over the place. Just because you can't see them doesn't mean they're not there. What's the modulus of 4? 4. Modulus of negative 3i. So on and so forth. Good?
Yeah.
Okay. This next part I'd like to burn through in about 1 minute, if you don't mind. So I do have to bring it up, and we'll go into more detail about this when we look at like how to do this graphically. But for today, I just would like someone write me a complex number. Ready, go. Just, is that it? Thank you. Give me another complex number.
17 plus 36.
Good. Listen, if I ask you to add 2 complex numbers together, it is exactly as easy as you think it is combining like terms. I don't expect ever, if someone says, do you want me to show work? I'd say, how could you? You can't. What is the real part of my sum? What's 2 plus 17? 19. And then I go plus 40i, and I'm done. I don't expect that we need another example on that. Adding complex numbers is a pretty simple process. Now, someone write me another complex number. 12 plus 3i. Thanks. This time I'm going to put a minus sign in the middle. Someone give me another complex number. Thank you. Okay, you guys are choosing standard complex numbers. You could have given me a real number. You could have given me a pure imaginary. At the end of the day, it really still just comes down to combining like terms. I would just caution you, you've heard this speech from me probably 3 times before in every other class we've done, that distributing the negative will either be why you get this right, or your stubborn refusal to do it will probably be why you get it wrong. So you can take it or leave it. I'm not going to challenge you and throw down like some kind of, boom, show me how smart you are. My advice to you has always been and always will be, distribute the negative, show your work. Not going to get any cool points with this guy for going like really fast. So my take here is let's leave the 12 plus 3i the same. And then let's go ahead and take that minus sign just like we always have ever since I met you in Algebra 1, and let's distribute it through. Give it a little bit of respect. It becomes a plus 6 and a minus 4i. You don't have to do that with a plus, but with a minus, that's what I would do. What's the real part of my answer going to be? 18 minus I. You can put 1i if you want to. Any questions about the plus and the minus? All right, in the last few minutes of this, I do want to get to multiplication of complex numbers, and it is the only remotely entertaining thing I think that we do in this lesson. I think to this point it's been pretty ho-hum, but multiplying complex numbers is actually kind of fun. So I've got a couple picked out here. Let's do 5 plus 2i times 3 minus 3i. You remember back in algebra when we multiplied binomials together, the FOIL process, how we did multiply, 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 multiply. You remember all that? We're going to do it again. So let's get started. Let's begin right here. What's 5 times 3? 15. I'm going to color code this for you. And of course, logically, any normal person next would probably head to the outside. Most people's brains say, let's stick with the 5 as our multiplier, but let's multiply him to the other dude over here. What's that going to be?
Negative 15i.
Negative 15i. And now mathematicians generally would say, okay, I'm done with the 5. Let's head on to the 2i. It's like it's his turn now. So the 2i is going to fly across and multiply to here. What do we get?
6i.
Plus 6i. And then this last one, the yellow one, is the last, right? The back end. What's it? Minus 6i squared. That just feels like algebra, right? But what makes this a little bit more fun, if you will, is this. Pop quiz. Does anybody know what I is? Hot dog. I is equal to the square root of -1. Don't worry, we'll have many more discussions about this in case you're a little rusty. But I is quite specifically the square root of -1. Having said that out loud, can anyone tell me what I squared is?
Maybe one, no.
It to me is the first time we really get a good look at why we call things imaginary numbers. It's the first time where you really just kind of go, what the what? I just squared something and got a negative answer. That is so against my nature. But knowing that is huge, because if I squared is equal to a real number, -1, then right here, I'm going to circle something in white. Right here at the end of this, what can I replace that white egg with? The -1, which means that the last term is really just a +6. Hot dog! It went from being this thing with I in it to just a 6, just like that, right? And now you can clean it up and finish the job. So what's the real part of our answer going to be?
27.
Ooh,
21.
21.
21.
And then the imaginary part,
-9.
presto. Good. It's kind of fun, huh?
So
And-
like vice versa, if that was +6, it would become an
Absolutely. So let's say we multiplied a couple of complex numbers together, and I'm just going to skip the first step. Let's say we got like 13 minus 2i plus 11i plus 5i squared. Since I'm low on time, I just wanted to get right to the ending of this one. What would this red egg, all of the red egg, really just become?
-5.
Just a minus and a 5. All the imaginary stuff goes away because I squared's like, boom, I got you. I'm just a -1. And so then you put it all together. What's 13 minus 5? And then 8 plus 9i, rest of done, right? So thanks to Mr. Clock here, I now know that I have to shut up. That pretty much got us through everything. There's one little thing I didn't get to, but I also don't want to make you late for lunch. So tomorrow we might start class with an example or two, but then tomorrow you'll have some time to work on a super simple assignment. I might even tomorrow teach you how to divide. We'll see.